Here we have a word problem. Statistics Canada estimates the population growth of different Canadian cities, and they predict Nunavut to grow annually by 0.8%. In 2009, the population was 30,000. So we can say in 2009, we know that the population is 30,000. What would it be expected to be in 2010 based on this data? Well, it's going to increase by 0.8%. How do you figure out using your calculator how to do that? How do we add 8% to something, or 0.8%?
30,000 times 0.008.
So 30,000, so we'll have to change it back to a decimal, right? 0.008, 240. So then the population would be 240?
No.
You add that amount to it. So then in 2010, it would be estimated to be 240 more. What about 2011? Could we continue the same thing? Okay, now we would have to take 30,240, multiply it by 0.008, and add 241.92. Probably 0.92 is we're talking about people here. It's not, not very nice to, you can't cut off a person's arm and say they're less of a person. So maybe we should round this up to 242. So now I could go to my calculator, and one thing that's getting me a little bit annoyed is always having to do a couple of calculations. So the question is, how could I do this so I wouldn't have to do that extra adding step? Any ideas how I go from here to here without having to multiply and add? Eric?
It comes by 1.008.
If I multiply it by 1.008. Now there's a couple of explanations of why this works. One, you could use, if I take 1.008 and I multiply that by 30,000, would you agree that that's the same as 1 plus 0.008? And if I think of it that way, and I distribute this 30,000, there's my 30,000 plus my new amount. And that 1 in front combines those two. Have you used this 1 point with a percentage before to figure out stuff? Do you use it with taxes? Something's going to be, it's $20, and you want to know what it's going to cost in Canada after taxes. You multiply by 1.13. The 1.3 is 13%, and the 1 in front adds the original amount to it because of this idea. So if we multiply by 1.008, we could get these values as well. So now I've got 2011, 2012, 2013. So I'm going to start off. There was 2009 times 1.008. That was 2010. Multiply that by 1.008. That was 2011, 2012, 2013. 30971.5, so I'll round that up. Oh man, is that right? Is that my memory? No. Nice. So we could figure out 2013 just this way, continuing the process. But if we're multiplying by something every time, that makes it a geometric sequence. So instead of trying to find 2049 by keep multiplying and counting it, we could use a formula. If this is a geometric sequence, We know that the formula for geometric sequences looks like this. We know term 1 is 30,000. We know that R, oops, one more zero. No, that was right. Perfect. We know that R is 1.008. Which term are we trying to find if we're trying to find 2049? Term 40? So, does that make sense? Now, what are we going to call this one then? Term 1. And this one is term 2. This one's term 3. And I want you to be careful with this, because if I do 2010 minus 2009, what number do I get? 1. And which term is term 2010? Term 2. If I do 2013 minus 2009, I get 4. But what term is 2013? Term 5. So 2049 minus 2009 is 40. What term will it be? Term 41. So if I'm finding term 41, that would mean multiplying by this. This is where the 40 shows up. 40 times. Type that into our calculator. Four, 1, 2, 6, 1. And if we read the question carefully, the question says, estimate the population each year to the nearest thousandth. So we're going to have to round this now to the nearest thousandth, approximately 41,000. This idea of percentage increase or percentage decrease is important. So here we had a percentage increase, and so we did 1 plus the value that was there. One of the questions that, I'll give you your homework questions, but we're going to do one together. Question 10, 13, 14, and 15. And we're going to do question 15 together right now. So, it's in part C, so that supposedly means it might be harder. A farmer in Saskatchewan. I like this because I grew up in a farm in Saskatchewan, so it's got to be a good question already. Wants to estimate the value of a new combine after several years of use. Certain things that you buy become worth less and less as time goes on, right? Your nice new shiny iPhone 4 isn't so nice and shiny anymore. I just upgraded from a 4, so. A new combine is worth $370,000, but its value depreciates by 10% each year. Estimate the value of the combine at the end of each of the first 5 years. So we can sort of put a chart up. We have the value at the beginning of the year, the value at the end of the year. And maybe I'll put year 1 at the beginning. It's worth $370,000. At the end of the year, it's worth 10% less. So we could do the same thing as we did last time, multiply and then subtract. Yeah. Okay, we could take $370,000, multiply it by 10%, find out that it's going to be worth $37,000 less, and then take $370,000 and subtract that value. If we wanted to find that value directly, it's the same idea as when we did a percentage increase. If you've got a 13% taxes, you multiply by 1 plus 0.13 or 1.13. If you want something to be a decrease, a 10% decrease, you would do 1 minus that value. If it's 10% less, it's 90% of what it was. So we can take and get this answer directly by multiplying by 0.9. Sure enough, that gives us our answer. So at the end of the year, and that would mean at the beginning of year 2, we would have 33,000. And at the end of year 2, I could take that answer and multiply it by 0.9. 299,700. I often find in these questions, starting off with a table like this really helps me see what's going on. It also helps me develop a sequence. Estimate the value at each of the end of the first 5 years. So in this case, they're really helping us to think of making a chart because we want to find 3, 4, and 5. And if we keep pushing enter on our calculator, there's end of year 3, end of year 4, end of year 5. Now I'm not going to write them down. They're there on the screen. You can type them out later if you'd like, or look at this again. What type of sequence did you write in part A? Well, this makes a geometric sequence. If we wanted to come up with a formula for this sequence, we have to make our decision. Is this our term 1? Do you want this to be your term 1?
Yeah.
Okay. So then I can make a formula for this that says term n is going to be term 1, r, which is 0.9, 90%, to the n minus 1. There's a formula, geometric. We've decided that 370,000 is term 1. Okay? Then in part B, it says, no, in part C, predict the value at the end of 10 years. According to our sequence, and the way that we set up our chart, term 2, is this the end of 2 years? No, this is the end of 1 year. Does that make sense? That the term 2, which we have here, was actually the end of year 1. Term 3, which would be right here, 299,700, is actually the end of year 2. So if we wanted to find the end of year 10, we would be finding term 11. And so I would plug everything in here. And this is going to be a little bit depressing from a farmer's perspective. If I type in $370,000 bracket 0.9 to the power 10, it's only worth $129,000 10 years later. You're losing a lot of money every year just on depreciation. Now, does someone have their textbook open? Because I'm curious, because I know that, is this what the answer key says? I think this is the reason I wanted to do this. 129,011. Yes, it does? Okay. Because there is I remember that it's either in the textbook or in the online program that I got alongside of it. Someone who did all of these questions made that mistake of figuring out term 10 instead of term 11. And it's an easy mistake to make. So I just want to make sure it wasn't your textbook part, which is good.